This video I'm going to go ahead and ask you guys for some help. And earlier I made a video about maybe doing some sort of crowdfunding to get a ready-built system for a CNC Scribe for the PlasmaCam, but I'm going to go ahead and say the hell with that and let's build our own system. So I've got a box right here. It's got a bunch of parts in it, and I'm gonna kind of go over what I want to do and ask for a little bit of advice as well, because you know that's how I learn, is ask, research, and hopefully somebody will tell me. But the idea is that my down pressure is going to be a pneumatic cylinder. It's got about, it's at 100 psi it's supposed to be 40 pounds, but I'm going to throttle that back to I don't know, 20, maybe less than 20. And that's going to be hooked up to it's got a filter regulator, and that's the easy part. See, on the other side of this branch, I've got what's going to be another filter regulator tied to I guess it'd be on this side, the automatic oiler, and that automatic oiler is what's going to supply oil and drive this little item, this pneumatic Scribe. So pretty straightforward, right? So where I'm going to need some assistance on this project, I guess, is in the controls portion. And so what I've got going on is, I know in the PlasmaCam and the little control box on it that it has 2 pins that would normally send or close and I've called PlasmaCam and I've asked them about this. What it normally does is it closes a switch, which is a solid state relay. And because it's a solid state relay, they operate on very, very, very low amperages. So they've told me that this relay cannot be, like, whatever I hook up to it, it cannot exceed 45 volts AC, 60 volts DC, and 100 milliamps. So what I was going to do is, with this pneumatic air Scribe, since it's not good for it to constantly, because it operates on beats per minute, like 10,000 beats per minute or something, it's not good for the Scribe tool, which is I believe carbide, to basically beat on the body of the Scribe, which, you know, more or less a soft metal, a stainless or aluminum, I'm not sure. And it's there's a dampener in there, but regardless, it's not good for it. It wants to have constant down pressure on material, and so the material that it's scribing is taking all that force out of it. So the idea is I want to have a solenoid turn this on and off with what would be the normal cutting signal for the plasma torch. Simple enough, right? So these solenoids that I found, doesn't really look like much until you take it apart, but it operates on 24 volts DC, so I'm in my, I figured I was in my DC range, or sure, my voltage range, but it can see anywhere from up to about 245 milliamps. So there's a little bit of a problem with that. And to get around this, and apparently this is a very common thing that people do, is they are I'm going to actuate this solenoid using this little dinky 24 volt DC still mechanical relay. So you can see up here in this window here, that's the mechanism, and you see the coil down here, the white part. So as voltage is applied to that coil, it magnifies and pulls this contact switch down and provides, you know, what you need. But regardless, so this piece is going to be what's taking the signal from the 2 pins on the PlasmaCam control unit, and then it's going to send a signal to the other solenoid, the one that's going to actuate the air pressure, and then it'll work. Somebody told me you should protect your solid state relay with diodes from the voltage that could backfeed once the mechanical relay, which, you know, it's using, for all intents and purposes, it is using an electromagnet. So electromagnets in that coil, they hold a charge, kind of, and so when you turn it off, some voltage is sitting in there and it can backfeed the system and possibly damage the solid state relay. I don't know. All I know is that this thing's supposed to operate at 30 milliamps, so I thought I was good when I got it. So, but somebody's like, yeah, you better do this. So that's the question, is how do I guess spec out diodes? I understand exactly what they're doing. I mean, they're preventing backflow, but I also understand that, you know, there's too much backflow that it'll burn up if you get too big of a one to prevent this backflow. That, I mean, it's got a voltage drop associated with it and all this nonsense, and my head hurts. How about yours? So that's the idea, and I think I'm going to get it. I've got it wrote down on paper. I'll probably do some screenshots or whatever and kind of do a voiceover on that as well. You don't have to listen to that part if you already got the first part, but that's the idea. And if you can provide me any help, I would appreciate that quite a bit. And this, so I'll turn this somewhat $1,000 item to PlasmaCam, and I think I'm making it for about, I don't know, $300 or $350. So thank you. And if you know anybody that can do some stuff like this, I very much appreciate it. Alright, so I've gone ahead and put a bunch of these fittings together, and I'm going to try and explain this a little bit better. And so it's basically happened. I got a quick connect here, so I'm going to bring air in, tee it off on the upper branch, shut off valve to a regulator, filter regulator, and then that's going to go up here to the air cylinder. And it's reason why it's a manual on-off valve is the air cylinder is pretty much going to be on the entire time that the program is running, so no real need for automation there. On the bottom side of this branch, I come over here, hit up the filter regulator, a automatic lubricator. This is the solenoid air valve, and then this is the air scribe. So that's my order of operations. The only other thing I'm thinking is the solenoid doesn't really need any lubrication, and it's kind of a best practice to get your regulator as close as possible to the object using it. So it may be that I flip-flop it like this so that it's going in air on off here automation wise, then the regulator, filter reg, and then lube. So that's kind of what that's going to look like anyways, I'm thinking. So any pointers on that would be pretty appreciated.